In this video, we are going to introduce the idea of a logarithm. And to do that, we want to look at some equations that we have solved before and a few equations that are going to be new to us. So here's a bunch of equations that we want to try to solve if possible. And notice these are all exponential equations because the variable is in the exponent. So the first equation is 4 to what power? 4 to the x power is equal to 4. We know 4 to the first power will equal 4, therefore x must equal 1 for this first equation. Now the second equation has 4 to the x power is equal to 10. Now notice, if we look at powers of 4, we know 4 to the first power is 4, we know 4 to the second power, 4 times 4 is 16, and 4 to the third power, 4 times 4 times 4 is 64, there is not a power of 4 that gives us exactly 10. So we're not able to solve this second equation quite yet. Look at the third equation. 4 to what power gives us 16? We know that 4 to the second power is equal to 16, so x is equal to 2. The fourth equation, 4 to the x power is equal to 20, that's another one that we can't solve right now because there isn't a power of 4 that we know that gives us exactly 20. And then the last equation, 4 to the x power is 64. We know 4 times 4 times 4 is 64, so 4 to the third power is 64. So right now we have these two equations that we're really not able to solve explicitly for x because there isn't a power of 4 that gives us exactly 10, and there isn't a power of 4 that gives us exactly 20. Now let's go back to the second equation. 4 to the power of x is equal to 10. Since 4 to the first power is 4 and 4 to the second power is 16, we would expect x to be some number between 1 and 2, which means x is a decimal. So for now, for the second equation, I'm just going to write x is some number between 1 and 2. Now for the fourth equation, 4 to the x power is equal to 20, we have a similar issue. Since 4 to the second power is 16 and 4 to the third power is 64, 20 is between 16 and 64, so we know x is a decimal again, and x will be a value or a number between 2 and 3. So for equations such as 4 to the x power equals 10 and 4 to the x power equals 20, where we know the value of the exponent is some sort of a decimal, then we need to find an inverse operation for raising 4 to the x power. And that's exactly what a logarithm is. A logarithmic function is the inverse of an exponential function. And we'll explore that relationship a little bit more later. For right now, to put it simply, a logarithm is just an exponent. So let's define a logarithm a little bit more concretely and introduce this new notation. So if x and b are both positive numbers and b is not equal to 1, then y is equal to log base b of x is called a logarithmic function with base b, where y equals log base b of x is equivalent to b to the power of y is equal to x. So get out your highlighter because it's important for you to highlight these two statements which are equivalent. These two statements I have highlighted in red both define the same relationship between x and y. So a little bit more of our new vocabulary here. Remember, b is called the base. And when we have a logarithm, b, which is our base, it's written as a subscript. So it is small and sunken down a little bit when we write it. Now, x is what you're taking the log of, and sometimes you'll see x in parentheses, sometimes without parentheses, but that is called the argument. The argument of the logarithm is what you're taking the log of. So again, the way we read this is y is equal to log base b of x. Now, looking at the exponential form, again, notice the base is b, so this is our base. And remember earlier, we said that a logarithm is simply an exponent. So when we have y is equal to log base b of x, this logarithm is equal to y, we see that the exponent is y. A logarithm is essentially an exponent. So the third bullet down here, remember, this is saying that these two expressions define the same relationship. So get out your highlighter once again. Y equals log base b of x is equivalent to b to the y power is equal to x. These are equivalent expressions. They define the same relationship. The first one is considered the logarithmic form of that equation, and the second one is considered the exponential form of the equation. So our first goal right now is just going to be to get comfortable going from exponential form to logarithmic form and back and forth. So take a look at our first example. Our exponential form here is 5 to the third power is equal to 125. So again, a few things to notice. In this case, the base is 5. 5 is getting raised to the third power, and remember that the 3 is our exponent. So when you go write that in its equivalent logarithmic form, the base, which was 5, remains the base. Remember this subscript, that's what we call the subscript. It's the base of the logarithm. It's going to be the same as the base in the exponential form. Now, what we called the argument, in this case, the argument is the 125. That's called the argument of the logarithm. And this logarithm is equal to 3. And remember that a logarithm is an exponent. So going back to that exponential form where the exponent was a 3, this logarithm is equal to 3. Now let's go over how you read both of these notations. The exponential form would be read 5 to the third power is equal to 125. However, the logarithmic form would be read log base 5 of 125 is equal to 3. It's really important that we can write the exponential form and the logarithmic form correctly, but we can also say them correctly. Remember, we're learning a new language here, so we want to be able to speak the language, we want to be able to write the language, and of course, understand it as well. So in our next examples, we are going to fill in this table just converting from exponential form to logarithmic form. Let's take a look at the first one that's given. So again, I'll highlight this logarithm here, and I want you to practice saying it in your head or perhaps even out loud with me. The proper way to say this would be log base A of 4 is equal to 5. So when we convert this into the exponential form, I always recommend that you start by identifying the base. In this case, the base is A. So we'll have a base of A in exponential form. And then remember, a logarithm is an exponent. So this would be A raised to the 5th power is equal to the argument, in this case is 4. So this would be A to the 5th power is equal to 4. Look at your second logarithm that's been given to us. We have log base 7 of 4 is equal to y. Again, it's really important that you try to say that correctly. Log base 7 of 4 is equal to y. Identify the base first. The base is 7, so that will become my base in exponential form. Then I sometimes call it looping around the equal sign. So that would be 7 to the y power is equal to the argument of 4. So 7 to the y power is equal to 4. That's going to be the exponential form. Look at our next example. Now this time, I've given you the exponential form, which is 2 to the 5th power is equal to 32. But I would still begin the same way. I would begin by identifying the base. So now the base of this exponential form is 2. So when you write this in log form, that means the base of your logarithm will be 2. Now remember, we don't write the entire word logarithm, we just abbreviate it, log. But if the base is 2, then you need to write that as a subscript. So it's small and sunken down a little bit, log base 2. But we still continue that looping motion where you go around the equal sign. So log base 2 of 32, so 32 is going to be our argument, is equal to the exponent, and the exponent is 5. Remember, a logarithm is an exponent. Our next example is 9 to the 0 power is equal to 1. So again, start off by identifying the base. This one has a base of 9. So in log form, the base will also be 9. That's a subscript. Log base 9. Then you loop around the equal sign. So log base 9 of 1, 1 is your argument, is equal to your exponent, and your exponent is 0. We would read that log base 9 of 1 is equal to 0. Finally, our last example is given to us in logarithmic form. So this is -2 is equal to log base 3 of 1/9. And you can certainly leave this the way it is currently written. But if you prefer to have the logarithm on the left side, then you could go ahead and rewrite it. Log base 3 of 1/9 is equal to -2. That just makes the logarithmic form look similar to the previous two examples that we did. Not necessary, but an option for you. And then once again, you want to identify the base. The base of this logarithm is 3. So when you write this in its exponential form, you're going to have 3 raised to the -2 power is equal to the argument, and the entire argument here is 1/9. 3 to the -2 power is equal to 1/9. So the most important skill when understanding logarithms is the ability to change from exponential form to logarithmic form, back and forth. If you can translate in between forms, then you will be set.